Hello, this is Nadir again. Today we are talking about data structures and algorithms, and we will focus about the principle of algorithms and data structure design. So, what is the data structure and why we use or why we need the data structure itself? The data structures, it means that's the method of positioning or positioning the data, okay, that allow us to get some benefit from it. It's represent in a way to allow us get some benefits behind it. So the data structures it will be represent in a different design, like a list, okay, like a tree, like a table, let's say also like array, graphs, linear, etc., etc., etc. So how we can get benefit f- from those kind of different structure of data? It's by some method, okay, by doing something, some action, by run some action on it. So that's why we use the algorithm. And this is design, or this is the definition of algorithm. Algorithms, it's some uh, st- some steps to get response for any questions you need on this data structure. For example, we want to find some element inside the list. We want to sort these tables. Okay, we want to insert some new element inside the tree. We want to delete one element, etc., etc., etc. So this is how we can get a benefit from a data structure, and how the method is the algorithms, which did on different type of algorithm: find, sort, insert, delete, etc., etc. So we will focus only for one actions, which is search and linear search. Exactly, let's go to deep, or let's go to details about this linear search and how and why we use this linear search. Linear search is known as a sequential search. Go through the entire list and try to find the element, okay, or fetch the match of the single element, and it will be a small comparison with each element, okay, until they find the desired element, okay. This is by the way, this is the simplest search algorithm in the search algorithms existing in the computer science, and exactly in data structure. There is a lot of course. We'll go for, after linear search, we'll go to the another type of algorithms. So the linear search is the sequential search algorithms, where we start from the the first element till the end element, and each element we have to stop there and compare, uh, and we have to search there and compare with the each element. Compare by what? By the given element. It's found or not. It's found or not. So this is how the linear search works. So let's go for some details in the and how it's going inside the array. For example, in when we search the linear, when we select the linear search, we have an array. For example, it's called array. Okay, let's make it a name array. Okay, the index I. Index means that the moving step by step. Okay, 1, 2, 3, 4, 5, 6. So it will represent the position. Okay, it will represent the position because we are moved, as we said before, we are moved from the beginning till the end. By the way, here always we have to start by 0, not by 1. Straight by 0. So how many elements we have now? We have 6 elements. We have 6 elements. In this example, we have 6 elements. Okay? So in this case, for example, let's, for example, erase this one. In this case, for example, we have pen. Okay. We have 6 elements, 24 till 17. And this is a component of the array itself. Okay? But this is the position of the index I. So, as we can say, as we said before, the end search is sequential search. Okay? Sequential means I have to move one by one. I don't have to skip or jump. Okay? I have to move one by one sequentially, okay, by index. Every time I have to add 1, okay, and starting from 0. Okay, for example, if I'm requested to find x which is equal 20, okay, which is the array 2, is not array 3, array 2, which is position 3. The position is 3, but array, the index, it's equal 2. Okay, see, this is how we can deal with the position and the array itself. So in the algorithm, which is the simplest algorithm in the search, linear algorithm, I mean, that means this starting from 0, okay, till end of the array itself, and every time I have to add 1, and we will try to search one by one and compare, as we mentioned before. Search, move and compare with each element, every element, until the desired element is found. So I'm searching, for example, till find the desired element. Okay, found here. Okay, by the way, sometimes we forget to make a break to stop the search. So in this case, the searching, it will continue till the end of the table, if I didn't make a break, there is no issue, but I will lose the efficiency of the algorithm. So efficiency of the algorithm means that it should be accurate, okay, and we have to make as short as possible space in data and time as well, which is very important. So for example, in this case, if I find the searching element, which is x equal 20, okay, I have to return I, element to represent in the list, so return the index position. Okay, so in this case, I equal 2, which is a position equal 20. I find it. Okay, position, I mean, sorry, the position is equal 3, but I equal 2. Okay, if I didn't find it, if I reach till the end of the array, I didn't find it, so the return it will be return will be -1. So element is not present in the list, means the element not found. So as I said, we have to make my algorithm efficient algorithm. That means if we find if we find the element, I have to stop. I have to stop. Okay. From another way, could be I didn't make a break on the. Could be there is no break. There is no break in the algorithm, but could be x. It's repeated twice. 20 here and 20 in the position number 4, for example. Suppose. So in this case, I have two positions equal 20. So in this case, I will take the first one. Okay, but this is not our subject for today. But just I want to bring some status or some cases. Could be a phishing when I am create the algorithm. Okay, before I go to the make it translate to the Java programming Java or C or Python or whatever. So in this case, if I find x, I will stop and I will mention the index, the position, and the index. So, like I mentioned here, if x is not found, okay, it will loop n time. Means I have to reach till the end of the table. Till the end of the table. This is the first. This is the first case. First case, which is represent the worst case. Worst case, if I don't found n, so I have to reach till the end of the array. That's what is represented by on. On means I consumed all the element and all the times that can be given to me to go through each element one by one, and I couldn't find it. Okay, this is the simplest scenario. Could be there is another scenario, which is, for example, I found it, but I didn't break the algorithm, so I have to go. But in this case, suppose I break. When I break and I stop. I break and I stop. Suppose for example, I find it the element in the beginning of the array. So in this case, I'm lucky. This is a lucky case. When I find the element in the beginning of the, let's go back. I'm searching, for example. Suppose, for example, I'm searching for 24 here. I'm searching for 24. It's not 20. When I start, oops, I find it in the first element. So I will return the position, return the value, and stop the algorithm and give the result. So in this case, this is a case which is called a lucky case. I find it in the first line. If I'm not, I have to go till the end of the duty and end of the time. Sorry, okay, and I called as a unlucky case. Okay, so the on it represents the time consuming. The time consuming is on. Could be the lucky case. Could be the n case. Worst case. Okay, so that's what it represent 1 plus 2 plus 3 plus t plus n. Okay, this is represent 1 plus divide 1 plus n plus 1 by 2. Okay, this is the total 1 plus 2 plus 3 plus n divided by n, which is equal, okay, n plus 1 divided by 2. This is how the search algorithm works. Okay, and we try to find to bring up the positive and negative point of the linear search. Okay, so the linear search algorithms is the simplest one. This very simple algorithm. Okay, very simple algorithm, but it's very slow. Why it's very slow? I have, as I mentioned, we have to start from the first one, okay, and I have to check the element one by one, okay, and goes through each element of the list until desired element is found. Otherwise, the search continue till the end of the data set or the array, as we make a test or make example here. So this is the principle of the uh, linear search algorithm. Okay, we don't want to take too much time in the linear search because we want to focus in another search algorithm type, which is binary search. Binary search. Okay, we will talk in details in the next session. Okay, I hope this it's clear and get some benefit and idea about the linear search and about the algorithm structure, data structure and algorithms. Thank you so much. See you later. Thank you.